So, hi Hado, hi Belle, hi Will. We just went through some stuff from exercise 5D, and there weren't too many issues with 5D. So we said, look, it was a bit choosy as to how far you went, and you didn't have to do every single question. It was just stretching our vectors situation. So we've already discussed now this next bit about parallelism. Parallelism? That's a hard word to say. Anyway, parallelism, that they can be parallel, doesn't necessarily have to be in the same direction, doesn't mean they have to be the same length if they're parallel. Okay, so you can see all of these are parallel. There's some missing ones where you find so find R and S. Oh, what did I times 2 by to make it become -3? Oops. To make it become -6. Brain leapt ahead. So times it by -3. So therefore R would be -1 times -3, which is +3. So, you know, if I'm saying we're skipping these, you're not missing much. Are you in agreement? We okay with that? Yep. So, question 2, go around. Start with you yesterday, Finlay. Will, because Will, not the Will at home, but the Will that's in the class. What can be deduced from the following? So 2-part A, what are we talking about there? Shall I come to you? PQ and 4A, what can you say about those two? PQ equals 4 lots of RS. So I'd say 1, they're parallel, but what else? PQ is 4 times the length of RS. So which one's longer? So PQ is 4 times as long as RS. But I have to always think about that. No, I go, So if I do, I'd have to draw it. And yeah, so you get the deal. So in this one, A, B, and C, D. So because the negative there, what would you expect to add to your description? It's going in the opposite direction. And of course, it's 2/3 the length of CD, but in the opposite direction. Sweet? We're burning through. We're not even going to bother. Ooh, I was about to say I'm not even going to bother with C, but have a look at it. What do you notice? It's So what is that telling you? They're on the same line. Collinear is what I was after. Very good. Collinear, and it's sort of being divided there. It's in a ratio. So, all good. Now, remind me, position vectors. What did that mean? The positions. They're being very comedic today. Very good. It's just, remember, it's from the origin. That's just all they're saying. So I don't feel like drawing 2D today, 3D. So remember back when we did the ships. If I've got the point 2, 4, and really that point is a bit more like 4, 2, but anyway, it's been one of those days. The position vector, if we call that A, the position vector there is OA, and that would be the vector, position vector 2, 4. So it's just from the origin. Don't get worried about any of that language. Shall we bother with 3? Really? Oh, okay. Let's do 3 then. Oh, 4. Find the unit vector. Yeah, I'm also going to say no. You're going to tell me. You're going to tell me how to do question 4. Because we did discuss this last lesson. Did I put the notes up or did I forget? I forgot? No. Oh. Okay, so find the unit vector in the direction. So what would this vector be for starters? Not unit, but vector. Excellent. So 2, remember it goes I, J, K. So 2, 0, 3. And who can remind me, I think Aman wants to play this game, how do we find the unit vector? Oh, you had to be here because everybody just swiveled around and looked at Aman. And when I say everybody, it's the naughty little row at the front. And who's in that row?
Ethan.
Dan.
Bobby. And Canal.
Oh, you did well. They're so funny. Right. So, head prefect, how do we find? Who can help out the head prefect? Dan the man? Another prefect. We'll handball from one prefect to the other. They don't want to talk on the video.
Hello there. You just got to multiply it by the what's it called? Modulus.
Some people call that the length, and we're not going to multiply it by the modulus. It's 1 over the length. 1 over. So we want to sort of say we divide by the length, but we're not going to. So if we talk about the modulus, as mystery student Gally said, right, this would be 2 squared plus 3 squared, so root 13, still got it. Therefore, our unit vector will just be 1 over root 13, 2, 0, 3. Okay, this is what we talked. Remember we talked a little bit about this last lesson. So simple things that you sort of forget, just you might want to pop them down somewhere or highlight. It says in the direction of, God knows, but if we go back and there's another question that says parallel, then we stick the plus or minus out the front. So, you know, what really is B and C asking us to do? Same thing. Do we need to do it? No way. Do you need a moment to write anything down? Say stop, you're going too fast. Correct. Absolutely. So Kunal just said he's going to use his old cheat sheet from last year. Absolutely. All right. Now, what if I now wanted, and let's say question 5 is pretty much like 4. So we go over here. This is a unit vector, which means it has length 1. So if you look at the next question, it's now saying find a vector of length 2 units, which is parallel. So what would you do?
I don't know.
Well, could you find the vector in the same direction, unit vector, that would be length 1? Yeah. Yes? Well, now I want it to be length 2. So I have it as length 1. All I have to do is now multiply by
2.
Correct. Right. So same sort of thing. So I don't know. Do you want to write yourself a little note at this point or not? Now might be the time. Yes, we're going to stick with the investigation on this one because I just got too panicked to go. If we do the wine glass, it'll be too late. I know. COVID. I mean, I've got my supplies with the spray and everything. So you're going to do 6 and 7. 7 we might do together. Prove that A, B, C are collinear. How would you prove that they are collinear? Yes, Kunal? Wait. Here I come.
You find the vectors for A, B, and B, C, and then prove that A, B, or B, C are multiples of one another.
Oh, I couldn't have said that better myself. So you would find AB. You would find the vector BC, and hopefully that one is a multiple of the other. So you could divide each term. We're assuming one would be 2 times the other or 3 times, but sometimes it could be a fraction, like 2/3. So you divide each value by. So yeah, let's have a go and do 6, 7, and maybe do 8. The ones with maybe do A and D. Oops, sorry, got started, forgot to record. So we're just giving you a little bit of a heads up with the 7, that we start with this point, A, and we're wanting to go in the same direction as this vector here, but for 6 units. So we use our position vector. So we're going to say OA plus AB, that's basically the gist. The position vector of the point 1, 3, minus 2 from the origin becomes the same thing but as a vector. We're going to work out the unit vector of this one that's in the same direction, then we times it by 6. So you will get that. You'll add it all. There will be some fractions. You use your calculator. Don't hurt your head. Okay? Feel free. Use your calculator. Imagine, imagine you end up with, and I'm going to put the answer over here because it's not the correct answer, but imagine you end up with the answer 7, 8, 9. You won't leave it like that because the question said, what's the point? So you'd say, therefore, the point is 7, 8, 9. You've got to be really specific now. I'm going to hammer you if you don't use the correct notation. So round brackets, horizontally, point. When you go vertically, then that represents a vector. And as I said, my old days, if we use the square brackets horizontally, that also meant vectors, but they're sort of fading those out. I'm now coming over to the dark side. So Mac attack, you wanted to go explain that bit again or not? You were explaining. Yeah, I heard that. Do you need to come and point or not? Okay. So also check daymap. I didn't want to put it up before the lesson started. Just had a little bit of a chat to see where you were, but we're cruising through the next couple of exercises. Let's just refresh. Please check daymap because we're not doing every single question that we are going through. And with that exercise, it was an F that we're doing with the with finding the angle between two vectors. You're going to do it by hand and by technology, and I can't for the life of me find my calculator. Where's my calculator's gone? Don't go yet. Now, a couple of things to remind you. When we are doing the angle between two vectors, calculator needs to be in degrees. Right? So if it was in radians from stuff before, make sure you're in degrees. Do you remember how do we get to an angle? You're nodding. Go, Aman. Option. Matrices. We go more. Here we go, angle. But you press angle and you go, yeah, well, now what? Well, this is the bit that annoys me and they really need to try and find something a little bit better. So I have to go and you could find a better way. Exit, exit. Now I'm in math and now I have to put in my 3x1 vector. Okay, so if I wanted to find the vector between 1, 2, 3, and then I go, comma, I do the next one. And pop that in. I think that will work. Try it. If it doesn't, well, we'll go back to the drawing board. But you can see how often I actually use this that I don't remember that bit. Ooh. So, what comes after the angle stuff? Because that doesn't take too long. I'll add a bit to daymap. You check it. You'll be right.